next presentation, I'm going to go through really the internals. You know, we've talked about a bunch of other stuff, but I'm going to kind of dig down into what's really kind of the guts of OpenShift, really not from necessarily from the end user's perspective, from the developer's perspective, about what are the servers, how do they communicate, what are sort of the nuances, some of the really kind of interesting, how do we really do this kind of really kind of high density multi-tenancy. I'm not going to talk too much about security. Dan over here will talk about that in a bit. But how do we actually go get hundreds, thousands of applications running on essentially one virtual machine or one node? How do we do all sorts of stuff inside? So this is all slides. There's no demo. I really hate to usually do this because I'll probably put everybody to sleep. So please, if there's questions, please really, if any kind of slides you've got questions of, hey, how does this routing really work? How are you really doing bindings, whatever? Please jump in and ask, because slides will put everybody to sleep. I just wanted to show my little definition slide again, because we're going to go through really what brokers, nodes, gears, all that kind of stuff is in this presentation. So it was mentioned earlier, OpenShift really doesn't care, as Krishna said, OpenShift doesn't really care where the provisioning kind of comes from underneath or what you're really sitting on. All we want is a properly configured Fedora or RHEL instance. So it can be, it could be OpenStack. We run it, up on top of EC2 and online, Rackspace. I'm going to show a demo. Krishna really deserves to kind of stand up and take a bow for some of the work he's done over the last couple of weeks of getting via Vagrant, getting VirtualBox, a VirtualBox VM to spin up, and that's what I'm going to show later. You go and you start it up, takes like 2 commands, let it sit for an hour, it pulls everything in, installs everything, and you've got, in a VirtualBox instance sitting on your box, you've got all of OpenShift. It's really cool, and that's what I'll jump into in the last precedent that I'll do today. VMware. I run it on VMware. I shouldn't say, I can say this because this is community, right? As a Red Hat person, I don't ever want to say that. Somebody will come to it. I've got VMware running on my Mac, so we can run, OpenShift on VMware if you want. And they're the 800-pound gorilla of the virtualization space, so you can absolutely, all the customers, potential customers that we're talking to are solidly running this stuff on VMware KVM. Okay, so and as Adam talked about, there's really kind of 2 different server types. There's the broker piece, and then there's the node piece. And typically you're going to run multiple instances of each one of these. Nodes for really how many apps do you want to go and be able to support, how many user applications. And then the brokers is really for dealing with kind of management scalability and high availability. So typically you'll have maybe 2 brokers to go and make sure that you've got kind of AK and you've got some scalability for people who are going and starting and stopping and creating applications. And then you're going to have some number of nodes depending on how many end users and applications you're going to have. Behind the broker, again, as I think Adam mentioned, there's a couple of pluggable pieces, and I think it's important to note, I don't think kind of plugins is on the definition slide, but plugins is kind of another idea that we've got where we probably will see a lot of kind of community contribution where a lot of the users, Origin users right now, are doing extensions or customizations, because this is how the broker is going to go and hook into your authentication and authorization, your security infrastructure. How you're going to go and integrate into your DNS. So it all comes out of the box, but the first thing that our enterprise users or the Origin users are going to do is, hey, my company has its DNS infrastructure. How do I go and integrate, not with the DNS that comes out of the box with this, but I want to integrate with the DNS infrastructure. Or I've got my corporate LDAP system that maintains all of my credentials for all my users. How do I go and integrate with that? So these are kind of the plug-in pieces, and there's APIs for these of where you would typically kind of go and extend an Origin. If you've got plugins that you're going to go right that you think are generic or kind of generally applicable to the community, please kind of contribute those back. Push in a pull request. We'd love to see them. In a lot of these cases, these are kind of very infrastructure dependent that may not be generally applicable, but if they are, we'd love to get them up there, and hopefully we'll have a kind of list of plugins for a lot of these at some point. The broker today is a Rails application. I would love to see it be a JBoss application someday, but I'm going to lose that fight, so I won't go down that road. So what happens inside of a node, the broker really exposes a REST API and is backed by a MongoDB that maintains really all of the metadata, handles all the stuff that we just talked about on the other slide. We're going to talk more about kind of the nodes, where the applications live, and what happens and all the coolness that happens inside of a node. So we've got now multi-tenants, real serious kind of multi-tenancy going on right here. And up and online, if you go look at it, you could have South Korea and North Korea having applications on the same node right now. These are two guys who don't really like each other and they don't want their applications sort of sitting on the same node. But we've got to make sure that these guys are completely kind of isolated from the other applications on that node, but yet still have the power, all the power that we can really kind of truly allow. So as Dan will show later, he'll talk about kind of how SE Linux works and how it does all the kind of compartmentalization for each one of the applications that lives inside of one of the nodes. So once we go in for every application is segmented for security for SE Linux, there's also another piece of how do we control the resources, because now we've got hundreds of thousands of applications running on one Linux instance. How do we go and control that some application is not going to be a runaway application to go and take all the CPU, take all the memory, essentially hog the whole box? So it's all really done through control groups, where we're going to be able to go in for that particular user, for that particular gear, and this is sort of that nebulous concept of a gear of it's got some sort of resource constraints. There isn't a process that's a gear. It's the user space that's created and all the kind of C groups control groups over that particular Linux user. So when an application first gets spun up, when you go say RHC app create, it's going to go through a whole bunch of steps, and I'll talk about this as we go through the slides. The first thing it's going to do is actually go create, in the simple case, I'll talk about scaled applications later, but for the simple non-scaled application case, it's going to go create a Linux user, and that's that UUID we've seen in kind of the demo. And it's going to go create a home directory for that user, and that's where all that application space is going to live. And it's going to go and create all the SE Linux constraints around that particular user, and it's also going to go and say, hey, these are the kind of the C groups things for this particular user. And for C groups, it's going to be based on the gear size. Lots of different gear sizes. You can say, hey, I want a small one that's going to give you a certain amount of memory, a certain number of processes or threads that guy can run. A medium gear is going to give you a little more. Those are the two that we support in online now. There's a whole bunch of categories. For Origin or for Enterprise, the sysadmins have complete control over what a gear means as far as the resource limits. And then inside of one of the gears, so once we've gone and spun that up, then that's when the actual cartridge comes into play. We've created the user, we've got the security around it, we've got the resource controls around it, and then I'm going to say, hey, somebody said I want a JBoss application. I'm going to go and take that cartridge and install that cartridge into the gear, into that new user space. I'll show you what directory it is, but inside of that user space, it's going to be installed from the cartridge. It's going to create all the whole directory structure, copy all the files, start the particular, that stack up, start up JBoss so the Java process comes up. And then for a non-scaled application, if you say, hey, go add me Postgres, in the case I think somebody had asked for Postgres earlier, what's going to happen is it's also going to install Postgres in that same gear, in that same single user space. It's going to go and spin up Postgres. So they're both, for the non-scaled application, I think this is important to note, that for a non-scaled application today, both of those guys are going to be living in the same gear. So they're both going to be having to use the same kind of resources. They're still going to be limited by the same kind of set of resource constraints. Can I bring that up because we'll talk about scale stuff too. Any questions, Dan?
So gear is basically a Linux container for
in the LXC space, it's C groups. I'm going to defer to a Linux guy because I'm not.
It's not a Linux container because we don't actually use LXC, but we use the kernel level C groups, which is which is also a technology that LXC utilizes.
Okay, so it's a lower level it's lower down in the kernel.
It's way too much.
Yeah,
I'll wait.
We both use the same mechanism for resource constraint. I'll say that.
But it's not.
We both use C groups.
There's no such thing as a Linux container, so stop with that concept.
Wow.
Is there another question?
Okay. So all the databases, you get an instance of database. You're not using shared database resource.
The broker uses a MongoDB for the broker's database, so to manage all of the metadata for users and accounts and all that kind of stuff. In the user space, each user or each application is spinning up instances of their own database. Nothing is shared. From the user space, nothing is shared, period, because that's the sort of North Korea, South Korea problem, right? Everything is really siloed and compartmentalized to make sure that they can't see each other. So when you want a database, you get your own database.
And actually, the process that runs your database has a different SE Linux context than every, like, so your gear has its own context, and Dan will go over that in like exponential detail, but.
If you write an app that, or you have two apps that share the same database,
Here's the application word overload, right? If we're talking OpenShift application, the answer to that today is no. And one of the things that's coming is, I don't know if we've come up with a term for it, but it's kind of a buddy system. That just right now when you go spin up an application that's called XYZ, and you say, I want to go and create a database for XYZ, the only person that can see that database is the XYZ application. And you're limited to one framework type, so it's a JBoss application that's talking to that database. What we want to be able to do is be able to say, hey, that's great, but I also want a Python application that's talking to that same database that also can maybe communicate, have all the configuration done so that JBoss can talk to the Python stack and have that all happen automatically. So we've got, I call it a buddy, I don't know what we're eventually going to call it, but on the relatively short-term roadmap is the ability to go and say, hey, I want a Python stack, I want a database stack, and all these guys may be running in different gears and part of conceptually, logically a different application, but actually know about each other, can see each other. That we relax the SE Linux controls there to let different applications see each other. Today, no.
Is there any concept of high availability?
I'll get to that with scaling. If you can hold that question for a couple of slides, I'll get to that with scaling. Any other questions? So a lot of cartridges come out of the box. If the best place to actually go look and see what cartridges is really either go look up in GitHub. If you go look at GitHub Origin server, there's a cartridges section underneath there. There's a cartridges directory under there that lists off a whole bunch of the cartridges. There are a couple of cartridges because of licensing stuff, like Zend aren't out in the Origin thing. In that cartridges area. There's also some community cartridges where this is where we encourage the community to come back and push to. So there's another Git repo that's under OpenShift. It's Origin Community cartridges. And there's 6 or 8 of them up there right now. There's a couple of different Python versions. There's a Tomcat one that I'll show later. Lots and lots of different cartridge types. Databases, all sorts of cron, all sorts of cool stuff. Yeah.
On the cartridges thing. So for versioning of those, let's say you have JBoss AS7.
Yep.
And then there's like 7.2.
Yep.
Is that cartridge version pushed out to all the apps that have installed that, or do they have to go and do the updates?
Yeah, I think there's actually, thank you for that question. I think there's really 2 interesting questions in there. One is, what's the policy that we're going to upgrade you guys as? And this is really speaking more towards online, right? I'll tell you what our online policy is, and then depending what the Origin or enterprise project is completely up to the sysadmins how they want to push this out. We want to maintain as best we can backwards compatibility. So we will upgrade, and I'll use JBoss as an example. EAP is the enterprise version of AS7 that's out there right now, and with EAP 6 you can go spin up a cartridge right now with EAP 6 and it's 6.0. Behind the scenes, a couple of sprints ago, so probably 6 weeks ago, you went to bed one night and you were running 6.0, and you woke up in the morning and you were running 6.01. You didn't know. We will upgrade that stuff behind as long as it's backwards compatible to the version before it. As soon as there's another version, and AS is the perfect case, that AS 7.1 is backwards compatible. So we'll upgrade 7.1 behind the scenes. As soon as there's a non-backwards compatible version, which 7.2 is, and is out, we'll offer 7.2 in parallel. And then you as the user have to go make the decision that you want to upgrade.
So if you were going to do, just speculate, if you're going to do it like in an Origin or enterprise environment, you'd have to basically have different cartridge names, RPMs, whatever else packaged differently to be able to support both.
The versions, and that's I think the other really important part of that question is, in cartridge V1, I'll talk about V1 and V2 in the last presentation of the day. Cartridge V1, cartridges were tied to versions. There was, and Python is a perfect example. There's a Python 2.6 cartridge, a Python 2.7 cartridge, and a Python 3.3 cartridge, I think, right? And that's problematic, right? There's so much overlap between those. There's a lot of just wasted code. It's just, it wasn't. So in V2, you actually create a Python cartridge, and one cartridge can support multiple versions. And the design of the cartridge, which I'll talk about later, is much better. But yeah, a lot of it has to do with kind of what's installed on the box, right? It is what version of JBoss is installed, and you do share whatever the cartridge are pointing at.
Yeah, there is.
Any other questions? Yeah.
High availability, is this
Yep.
a good time to ask?
This is the slide. Perfect time.
Database?
Not yet. So with scaling, when you go and create an application like we've seen, you get everything really essentially running inside of one gear. You go create your JBoss stack, Python stack, whatever. You add a database, it all runs inside of that same gear. That's great for development. When you really want to go and scale this stuff out, if you just pass the -s flag in, it's going to say, hey, create me a scaled or scalable application. And this is essentially what happens. You're going to get multiple gears, or potentially multiple gears now, all running inside of the same application. Horrible term again. But what happens when you go and create a scaled app, and I'll stick with JBoss, it'll spin up a JBoss stack. It's also going to go and spin up an HA proxy instance on the primary gear. So you've got one JBoss running with HA proxy, and that HA proxy instance is going to be the load balancer for your scaled application. And then if you go and scale up your application, go say, hey, I actually want 2 instances of JBoss. It'll go spin up a second gear where there's a JBoss stack. The HA proxy on the primary node will get updated and start load balancing automatically between those 2 gears. Yeah.
Can you guarantee, or is there a flag you can give to say that these are on multiple machines so that if you're not tied to, your application isn't tied to one machine?
In online, we do that automatically to make sure that there is, if one of the nodes actually goes down. And you can control that for Origin and Enterprise. A lot of the kind of answers like that are going to be sure you can do that. We do that for online today, so you could absolutely do that in Origin. A lot of that has to do, like in Origin, if you're running with one node, there's nothing you can do. But yeah, we do that now. If it's possible, if there's a node that can host the other gear, we'll put it on another node. Yeah.
Is there an easy upgrade process if you start out as a non-scalable and to move to scalable?
No. That's a problem we recognize, and one of the things we're kind of re-architecting right now is at the kind of implementation level, every application will be scaled. And whether you decide to flip it on or not, then it's up to you. Today, there isn't an easy upgrade. You've got to, what you really do is you've got to go and create a scale that you can take a snapshot of.
Just redeploy your code.
Yeah, I haven't found that to be a particular problem for me, because usually I could restore my app from GitHub, or if it's a Git repo that you can use as your starter, then you can have a kind of staging quality and then a scaled quality, production quality, that's a separate tier.
And there, with command line tools, there's also RHC snapshot that will snapshot your app along with the database information. And then if you create a scaled app in OpenShift like nomenclature and then restore from that snapshot, then it's scaled.
Okay.
It's not a pretty solution, but it's how it's possible right now. In the future, like I said, we're gonna make
We've got it's going on right now to fix that, to make everything from the implementation perspective scalable, and whether it's scaled or not is then becomes up to the user versus having to make some arbitrary choice.
Okay.
Yeah.
So if you, let me get to this or not, I don't know. So if you have anything like in the data driver that has to be persisted, that makes it not scalable initially, right?
Yeah, these are all really great questions. That's another problem we're working to solve right now, is that we don't have a shared data solution yet. We're evaluating a whole bunch of technologies about, at least for online, for what an Origin user would do would probably be up to whatever they want to use, but we're looking at a couple of different technologies to do shared data between scaled apps and gear. So anything in that persistent data directory right now, if you want to replicate it, that's on you.
Yeah, because like if you take for example like the Drupal quick start that's out there, the way that's created, that actually can't be scalable.
Because it has data in the data directory.
It puts the Drupal install in the
Right.
So
Yeah.
this is also going back into how you actually architect your own application. If you want your application to scale infinitely, you want it to be as stateless as possible,
Yeah.
so that you can push state to, sorry?
Be careful with that infinite term.
Applications. Yeah.
Calm down.
But you know.
I have a question on the HA proxy. You said the HA proxy lives on the primary gear.
Yeah,
So what happens if the primary gear goes down?
your host.
So the application is gone. There's no
You can't route your application anymore. So there's two single points of failure, and that slide brings this, we're not trying to hide anything right now. There's two, we are working on this today, and actually we're making it, this is kind of part of the cartridge V2 work that I'll talk about later, to make not only that problem go away, but also to have it pluggable. We decided early on that HA proxy will be your load balancer, so when you create a scaled application, you get HA proxy. From a JBoss guy, HA proxy is not a great load balancer for JBoss apps. JBoss has Apache with mod cluster that does a much, much better job. So we want to be able to plug in, let you decide, hey, I'm going to create an app, I'm going to create a Python app. Wait, I want it scaled. And when you scale it, here's the load balancing implementation. There's another cartridge, add me this load balancer. And if we can go spin up multiple versions of that load balancer, so then you have HA with the load balancing tier. This for the database stuff is so database specific based on what database implementation is to make this scalable. We're working with a whole bunch of partners. Thank goodness we've got partners for a lot of the databases out there that are that they are taking the responsibility in some sense of making scalable cartridges, right? But that's going to be very kind of different based on whether they're hot and cold, whether you're running really parallel instances of a database. It's going to be very database implementation specific. But we're working with a lot of partners to scale this tier, and that one we're working on ourselves.
Do you have like integration with things like the Red Dwarf project in OpenStack, like databases to service stuff?
I don't know. I'll have to defer to an OpenStack guy.
If you have any services running outside of OpenShift, outgoing network connections from the gears are totally possible. So any services running outside of OpenShift, you can connect to. So
Yeah,
I'm
I
assuming,
mean, like say you're deploying you wanted to use like, say you have like MySQL as a service and other different things like that.
Yep.
Have it use like the underlying stuff instead of spawning new VMs. Because you might have like, this stuff might be running on like physically there with SSD disks instead of spawning virtual machines.
We're not spawning virtual
Yeah,
machines.
we have no virtual machines.
Okay.
A gear is not a VM.
Yeah, but it's running inside of VM, isn't it?
It's running inside of Linux. Linux may or may not be in a
Oh.
VM, but it's running inside of Linux.
But I mean, you can run OpenShift on bare metal if you want, and it just carves it up at the OS layer. So we do multi-tenancy at the OS layer instead of on top of some type of bird stack.
And you can definitely connect, it would be manual, if there's a database, and if there's an Oracle database that's sitting out, you're running Origin or the enterprise version, you want to connect, right, I know, but that you connect to some database that's in your infrastructure, right? You want to connect to it, there's nothing to stop you from doing that. We don't have a XYZ database cartridge, right? But you could go either create one on your own or just configure the stack that you've got to point to your database. It's this, when we go and embed MySQL, Postgres, Mongo, all the integration between here we do for you. There's nothing you need to do. We do all that integration ourselves.
There'd be no problem creating a cartridge which doesn't contain any actual software code, it just points at an external database service.
Yeah, we've got a do-it-yourself cartridge now that essentially spins up an empty gear. So there sort of already is that. But if you
I
want,
think he's talking about a plug-in cartridge. So I have a cartridge that doesn't start MySQL, but you just set the environment variables for where it is. I want to publish that to
yeah, that'd be really easy to write. Yeah.
Like a custom in-house kind of thing.
Yeah, right, a cartridge that just automatically does the pub sub to configure everything. Yeah, that'd be really easy to write. It'd be a very little cartridge.
Can we do it this afternoon?
Yeah.
All right.
You're the lead on that.
I have to just feel for it.
Well played.
The other piece I'll just touch on kind of quick is the messaging piece, the M collective piece that kind of sits in between. So how do the brokers and the nodes communicate? You come up as a user, say, hey, create me a JBoss application. You're talking to the REST API, to the broker. The broker goes, what happens then? The broker says, okay, the guy's, he's got an account, he's authorized, all that stuff's great. And then there's the communication mechanism is mCollective that the broker uses, talks to all the nodes, and it'll send out a message to all the nodes. So there's an mCollective client kind of thing, and it's really kind of straight messaging. It's ActiveMQ or Qubit or whatever you want underneath. It'll send out a message to say, hey, all you nodes out there, somebody has asked for a JBoss medium gear. Can you handle this? And the nodes will come back and say, yep, I've got space, I've got gear space to go and handle that. And then the broker will send a message back and say, okay, you're the guy, go and install this particular application on the node. So all that kind of inner broker, between the broker and the node goes through this messaging system. One of the things that we're also looking at doing is making it, that kind of algorithm about how to make a decision about where it goes more flexible. That you could have, that's something we've been talking about a lot, and I'd love to kind of hear what the feedback was, is if you've got different things installed. Right now all the nodes are pretty much homogeneous about what cartridges are installed. But what if you had a couple of different groups of nodes that, hey, this node has these versions of Python and these versions of the database, and these ones have this different versions of Python and different versions of the database. And then if a user came in and said, hey, I want Python 2.7, it would automatically go and get maybe the version of the database that coincides with that you want this kind of stack to play with this kind of database. Anyway, we kind of stuff we're looking at about making that decision process more flexible, more configurable, more intelligent. Okay, HTTP flow. So if you go back and look at the little kind of template app, you've got a browser out there, you've created your application. No communication to the broker anymore. Once your app is created, the user's not talking to the broker anymore unless he's just saying start, stop, delete. That management stuff goes to the broker. Everything else, once you've gone and created your app, your browser, your Git, whatever you're doing to go push applications is talking straight to the node. How do we handle this? This is really, really a big one. And when you go to run into cartridges, when you're writing cartridges, this is something that you've really kind of got to understand about how we handle this multi-tenancy. Because each one of these nodes really has only got one real routable, one real IP address. So we've got an Apache running on every node, and that Apache is doing multiplexing for all the HTTP traffic that comes in. And we've got, say in this case, we've got a couple of different gears running that are running two different applications. Each one of those applications is binding to a unique loopback, a 127 dot something. And it's got its set of ports, so we don't have any port conflicts because everybody's got a unique loopback. But those applications are not directly routable. Everything gets proxied through, all the external traffic gets proxied through this Apache proxy that's sitting on the node. Any questions here? This is a big, when you start to write cartridges or try to deploy an application to OpenShift and you go, hey, that's cool, I'm going to stick it on, I've got a JBoss application, but I'm actually sticking something on top of it, and I just want to bind, because I want to go and I'm binding to something, I need to listen on a particular port. They try to bind to localhost, or they try to bind to the actual 10, whatever it is, address that's up in EC2, and boom, it blows up, and SELinux says, nope, you can't do that. Is there a question? Okay.
What do you bind to?
Excuse me?
What do you bind to?
You bind to the unique loopback, which is an environmental variable that's made available to your application that says, and it's,
Okay.
you can pull it from your app, and that's the one you've got to bind to. And there's also a list of ports that SELinux will allow you to bind to, but you've got to bind to that unique loopback.
And
You can do
that,
that symbolically, there's an environment variable.
Yeah.
and that local IP address varies by application.
It gets right, because when you go and create an application, that unique address is assigned to you. Yeah.
There's a different address per gear.
Yeah. This is a big one. I mean, I'd say, I don't know if there's a significant percentage of users who go and deploy applications and they run right into this. Hey, my application pulls up, it works great on my laptop, or works great on my server. Boom, why doesn't it work up there? And you go and dig through the logs and it's, hey, there's a binding permission problem, and that's it. So typically that's really one of the things, you're going to real kind of major things different between when you run locally and when you're running in online, are really important. 10,000 foot view. So I kind of want to take it really from this side for us, right? What are really the interfaces that the user is going to see, and who's he talking to, and what's happening? All of the dev tools, command line, the GUI, the console, there's a Java client if you're using the Eclipse plugins. Any of that stuff is talking to the broker, and the broker is going to handle all that management stuff. The broker is going to talk to the nodes, and then the interfaces to the actual applications themselves are either Git or it's HTTP.
So it's get over SSH.
SSH, yeah, well, I'll actually, when in the real kind of quick demo, because you're creating a user, when you go and create an application, it creates you a Linux user, and you're going, and part of that process is your account has certificates associated with, keys and certificates. So it's actually going to go and associate with that particular user your certificate so that you can now SSH up into that gear. So you can do that. That's what right in the beginning of the demo. The first thing, you create an application and SSH into that application so you can see your directory space, and you can see what's in the data directory. You can make whatever kind of local changes you want to do, look at the logs, whatever. Is there another question? Okay. We're looking at, particularly for Origin and Enterprise, coming up with something out of the box that does non-HTTP multiplexing so that you can expose protocols that aren't HTTP based necessarily. So you could talk to a database, from, you could have your database client living outside of OpenShift and talk to it, or a messaging system, or whatever, a data grid, you name it. So we're looking at doing that. There's problems with, really with EC2, but for Origin stuff, it's really not a technical challenge, it's just a more we've got to do there. One question in the back? Yeah.
So are you saying you couldn't establish a socket connection from like a raw socket connection? It has to be
straight to your app?
Yeah.
Nope.
Okay.
Unless it's HTTP, you can through port forwarding. The part of the REST API, and so you can do through the tools is go and actually set up SSL tunnels to go and do it. It's not a production. It's great for dev, but certainly not something we'd recommend to do in production. You could do it that way, but we're looking at doing more kind of TCP multiplexing. Really more probably for Origin and Enterprise. Yeah.
So, you set up a user, you set up a home directory for that user.
Yep.
And then you're scaled out. Does everybody have, or do you have a shared home directory if you're across multiple machines? Or
No, every
once
gear
it's
has its own directory, and every gear has its own. So a gear is a Linux user with its own directory space. Every gear, and an application could span multiple gears. So when you say create me a scalable JBoss app, it creates the HA proc, creates you one Linux user inside of it with its directory space, and inside of that space is running an HA proxy instance and your JBoss instance. As soon as you say I want to scale up, it's going to go create another Linux user on another box that's available, create another Linux user, spin up the JBoss in with its own space. It'll do the configuration, so all the cool magical clustering and stuff happens.
So what I'll get back is I'll have multiple users, and if I log in as that user, I'll be on that machine and that gear. And if I go in as the other user, I'll be on the other machine.
That's right. That's right. Yep. I should also mention.
I think this comes a little bit back to the shared data and everything. Today, no, but working on it.
Coming. Yeah, Gluster's. Gluster was an acquisition that Red Hat made a while back, so Gluster's certainly one of the options we're looking at to provide that. Yeah.
So then how does, I can probably look it up actually, I just threw a question out there. So how, like if you do RC app SSH, and you've got a scaled app, how does that work? What do you log into?
You into the primary gear.
Yeah, the one that's running the HA proxy.
You go to the primary gear, yeah. I should also mention with scaling, I think I forgot to mention this on the scale slide, for online, and you can do this with Origin too, there's auto scaling enabled if you go and create a scaled app. We'll actually auto scale your app up and down based on traffic that's going through HA proxy. You can turn that on and off if you want from the user's perspective. However, there's a Ruby daemon that runs in the background that says, hey, there's an awful lot of traffic coming through here, and the usage for the number of threads or whatever that's available has hit some threshold. I'm automatically going to go spin up another gear for this guy as soon as it comes up, it'll start load balancing, and then as soon as the traffic drops, it'll wait some period of time and bring this other node down. So there is an auto scaling capability, and I think that's pretty big. I think I forgot to mention that.
So what happens to things like logs and stuff like that when it when it shrinks?
They're gone.
Do you have any shared logging plays?
No,
or
that's
using
part of the kind of the
log stacks or
shared,
something?
that's part of the shared, that's one of the problems of not having a shared data store to go do that. I'm not gonna say that it's sort of ready for the kind of couple of obvious reasons for that, and for the single points of failure of the database, single points of failure of agent proxy, right? We're getting there, that we definitely know there's some steps we gotta do before that's really probably production ready.
Have you thought about syslog or log stacks or something that's stored in one
Yeah.
place?
Yes. So as far as log aggregation, we have been working on kind of proof of concept with a few different ones. Logstash was one of them. We even looked at doing a plugin for Splunk, but nothing's really panned out enough to make it there. But we recognize that is a problem, and we are looking for options to fix it.
Okay, so that's all I've got for kind of the internal slides. There's just a couple here that I'm gonna go, these are sort of plugs for where to go look. And I'm telling you, I cannot highlight this. I will show this at the very, very end of the day as part of my cartridge thing. This is the stuff that Krishna did. I think this is really the coolest thing in the whole. First, go spend 5 minutes if you have it online. Go spin it up, it's free. You've got some free applications, play around with it. If you say, wow, this is cool, the next step that I really recommend is go to that link, 2 simple little commands, kick it off, and you will have Origin running on your laptop or on your server, and we'll sit and wait for an hour while it downloads and configures everything, and then you've got a VM running with all of OpenShift sitting on your box. You have to do that, it's great. And the other thing is it's always going to be pulling from Origin. You want to go spin up another one, go, if you want to go get the latest, spin up another one and do some updates, and you're good to go.
You do that on bare metal? I got a
Yeah.
crash and burn box at home.
Vagrant won't run against bare metal, but internally that is using the Puppet scripts and you can run that.
Okay.
Yeah, so in the docs on OpenShift.github.io talk about how to deploy using the Puppet. You can use that right on bare metal.
Okay, because I've got this box at home and not good for much anything else.
Yeah, give it a shot.
Yeah, I mean, it's this Fedora 18 is the, and so for F17 or for F18,
At this point, I think F17 is probably a bit dated, so you don't want to use 17, use 18 instead. And I've also moved these instructions onto the GitHub.io site, so you can see it all there. It's all in one.
It's on 18 now. It's actually triple booted, but it's on 18 now. In fact, I've been thinking of moving it to 19.
19 is probably too early for 19, because 19 is going to Ruby 2.0 and probably the next version of Rails as well, so there's changes required.
Yeah, we've got that.
We are, however, we are working on, so we have OpenShift Origin. It won't be the full spiel that you can build off of the source in Git, but it's going to be the broker of the node and a handful of cartridges. We're working on making a Fedora feature. However, Fedora moves really fast, so we are continuing to work on it, but that is on the roadmap.
But it'd be in 20?
We hope to make it in 19. We're trying. We're trying to make it in 19. If not, we'll have to push back to 20. But as soon as possible, we'll have it in as an official feature.
Your website is down right now.
Or might be,
So instead, go to OpenShift.github.io and the Puppet and the Vagrant scripts are there, so they'll just repeat that. And, are you running that on OpenShift.com?
One of the real reasons I think go to this is even when you go up online, you play around with it, you can SSH in and see your little very scoped directory of what your application is. Everybody, particularly kind of sysadmins, are like, what is really going on up here? Like, I want to go see what Apache's doing, what Apache on the node is doing, how is all this stuff really configured? And the great thing to do really for this is, from the sysadmin side, is you can see everything running in one box. You can see all the config, you can twiddle with it, you can do anything you want. And for cartridge development, this is also really a great development environment. Instead of having to go stand on multiple servers and stuff, in an hour, start to finish, it takes you 1 second, it just takes an hour to get it set up. Now you've got a development environment for going to create your own cartridges, or hey, I want to play with a different authentication plugin. And that's a great environment to do it. I'm just curious, and I want to see what's really running underneath the covers, more from it than just what the user sees. That's a really easy way to go do it. Just a couple other really kind of quick slides that come out of time. There's a bunch of IRC channels, email lists, really they're kind of separated between whether you're a user or whether you're a kind of community developer. If you're a user, there's a users list and pound OpenShift to go in and hey, I'm a user, I try to create an application, I'm having a problem. And then there's 2 dev versions that if you're running Origin locally and you're trying to Origin locally and or you're trying to write a cartridge or a plugin or extend the kind of core broker technology or something like that, those are the other kind of channels. There's also a newer one that if you're really kind of interested in the node and specifically developing cartridges, there's also a dev node one that's relatively new. We're up there all the time. There's lots and lots and lots of Red Hat OpenShift people, and particularly in this room, there's a lot of, the community here is really pretty healthy outside of just what, is the Red Hat folks, and people who will be answering questions for you or have got a lot of experience with OpenShift that can help you out, may or may not be a Red Hat.
Also on Pound OpenShift, some of the ops team from online hangs out there. So if you're having a problem and it needs attention from ops, we're out there.
Forums, blogs, I think that's all.
All right. Well, so that's everything.
That's it.
You got it all? Everybody got everything? All the internals,
All
deep dives, everything? You're gonna write a cartridge this afternoon? It's all good?
I'm gonna go re-implement
So, all right. Now for the really good stuff. All right. So,
Get out a notepad.
we're gonna forget out your pens and pencils, yes, and start writing this stuff down. The next up is Dan Walsh. So if you need coffee, get coffee. But let's